Welcome back to the Lowdown on Physics. This is screencast number 1 in Unit 4 Physics Elective Structures and Materials. Today we will be looking at the forces that act on structures. Before we go any further, I just want to have a look at the context that we're looking at for this topic. Basically, we're looking at the materials used to build big, really large structures such as bridges or skyscrapers. These things need to be able to withstand enormous forces, not just the force on the structure itself, but things like the weight of that structure, the traffic that may pass over it, wind blowing against it, and even the ground pushing up on that structure. All of these forces are going to cause the structure to stretch or compress, deform or bend. So we're going to analyse the effect of these forces and how we can use different materials to compensate for the forces it's going to experience. So just a quick definition before we get going any further, and that is that of a load. And when we talk about load, we're basically just referring to the force that is going to be acting on a structure. Pretty straightforward. Just keep that in the back of your mind though when we talk about it, because you'll hear it a lot throughout this topic. There are 4 main types of forces. So what I'll do is I'll name each of them and we'll talk about each of them in a little bit more detail. So firstly we have a compression force, tension force, which is effectively the opposite. We've got shear forces, and then we have bending forces. So firstly, compression forces. These are forces that are going to compress the atoms in the structure. They're going to push everything together. The effect that will have is that it will decrease the length of the material, hence compression. Not a rocket science yet. Okay, so stronger forces obviously will cause greater compression. So the more force that you apply, the more compression that will be experienced by that material, and the effective result will be crushing or buckling, bowing and warping of the material. Tension forces, well, when you put something under tension you're trying to stretch it or pull it apart, so that's exactly the effect that it's having on the structures in the atom. It's trying to pull them apart, and as would be logical, we get an increase in the length of the material, and as before, greater force will result in greater increase in the length. So stronger forces cause greater tension and therefore greater stretch. Result can often be cracking or permanent stretching and tearing of the material that you're using. The third type of force that we have is a shear force, and this is where the forces are acting kind of like compression. They're pushing, but they are not in line. And basically what it does is it causes the atoms to slide over top of one another. So our forces, if we want to use the correct terminology, are not collinear. Collinear means that they're all within a line. So the forces are parallel but not in line. So the result is no significant change in the dimensions, but there will be a change in shape. It's what we call deformation. So just an example there is shear on a thick book. You've got friction pushing it one way and your hand pushing on top the other way. We get that classic shear sort of shape. Same thing happens often when we're using an eraser trying to rub out some pencil on a piece of paper. Finally, bending forces, and they cause a change in the shape of the structure, or the material rather. Basically the result is, instead of it being straight or flat, we end up with a curve in the structure. And the reason is we're getting compression on one side of the material and we're actually causing tension on the other. So if we look here, on the top all of the atoms are being pushed closer together. On the bottom they're actually being forced apart. So we have an area of compression on top, area of tension on the bottom. And another diagrammatic representation here in the case of the springboard, all of the atoms are being pushed apart on top and being squash closer together on the bottom. So we have compression here, tension on the bottom. That's often a question that will pop up in the elective, is identifying areas of tension and compression, or more frequently is how you would reinforce, say, concrete to combat the areas of compression and tension, but we'll get down to that a little bit later on. And the reality is that most structures do have compressive and tensile forces acting at exactly the same time. So if we look at, say, a simple beam that's just supported at both ends, the beam actually has a mass, and that weight can be considered to be acting through a single point, which we call the center of mass. So if you pick up a chair or any object, there is usually a single point that you can balance that object at, and that's what we call the center of mass. If it's a uniform object, it's usually in the center. For non-uniform objects, say a cricket bat, it will be much closer to one end. So we see here areas of compression. Atoms don't like it, they're being a bit squashed up, yet on the bottom, happy times, we've got more space for those in tension. So that's it for forces that are acting on materials. Next screencast, we will actually start to look at the effect of these forces.